Okay, to illustrate recursion here, I want to start with an example that I usually use with my students in my class. It'll be a little bit harder since we're not together, but I'll try to illustrate it here. So what I normally do is I get students to line up in front of and standing on the wall. I have them close their eyes and just kind of position them next to a wall. Again, have their eyes closed. Then I go to some random student kind of in the middle, and I'll ask them how many students are in front of them. Well, obviously they don't know, so they can't answer because they have their eyes closed. So the idea is that they'll ask the person in front of them, how many people are in front of you? And they say, I don't know. And that's the next person. How many people are in front of you? I don't know. That's the next person. How many people are in front of you? And the person that's standing against the wall has got his hand against the wall. He says, done. I know I'm against the wall. So then he tells the person, there's nobody in front of me. So there's one person. And so this guy says, okay, there's one person in front of me. This guy says, there's two people in front of me. And then he tells back and says, okay, there must be three people in front of me. So that's how recursion works. This case right here, when we finally get to an answer, where the guy does know, the guy worker does know how many people are in front of the wall. That's called the base case. So that's how recursion works. And then it will trace back and we will get our answer. Okay, so that's how recursion works. So I'll show you the kind of classic examples of recursion that actually deal with code. The first one is factorial. So like 5 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1, which is 20, 60, that's 120. Okay, so 5 factorial is 120. Now, the idea is if you're doing 5 factorial, you could just say, well, I don't know what 5 factorial is, but I know it's 5 times 4 factorial. Right? Because 4 factorial is 4 times 3 times 2 times 1. And it's just times 5. And 4 factorial would say, well, I don't know what I am either, but I know I am 4 times 3 factorial. 3 factorial will say, I don't know, but I'm 3 times 2 factorial. 2 factorial says, I don't know, but I am 2 times 1 factorial. And really your base case could be 1 or 0 here because they're both 1. So let's just say 1 is our base case. And we know that 1 factorial is going to be 1. So we get, 1 factorial is 1 times 2. That makes 2 factorial 2. 3 times 2 is 6. That makes 3 factorial 6. 4 times 6 is 24. That makes 4 factorial 24. And 5 times 24 is 120, which is 5 factorial. So that's how recursion works, okay? So we'll show that in BlueJ in just a second. So the other example would be the Fibonacci numbers. And if you're not familiar with that, I'll show that what that is. It's a list of numbers created like this. Starts with 0, 1. And then every other number is the sum of the previous two numbers. So that's 1. Now it's 1 plus 1 is 2. Now 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. Okay, that's how it works. So the same thing. If you're asking, let's say this is the, let's say Fibonacci numbers start with index 0, and there's kind of a couple different definitions for that. N equals 6, n equals 7. So the 7th Fibonacci number would be 13. So if 13, or if we said, okay, give me the 7th Fibonacci number, and we'd say, I don't know, but I know that I'm the sum of the two numbers before me. So I'm Fibonacci of 5 plus Fibonacci of 6. And Fibonacci of 5 and Fibonacci of 6 would basically say, okay, I'm the two previous of that. I'll actually show us a shorter example because it kind of a lot to trace. So let's do Fibonacci of 3. Fibonacci of 3 would be Fibonacci of 2 plus Fibonacci of 1. And neither one of these two things are our base case. Or actually, our base case is Fibonacci of 1. These two are our base case. We have two base cases here. Both of those are defined. and all the other ones are defined based on that. So Fibonacci of 1 would just be 1. Fibonacci of 2 is Fibonacci of 1 plus Fibonacci of 0, which are both the base case. Okay, so Fibonacci of 1 we know is 1, Fibonacci of 0 is 0. So that makes Fibonacci of 2 the sum of 1 plus 0, that becomes 1. Okay, so Fibonacci of 2 is 1, Fibonacci of 1 is 1, which makes Fibonacci of 3 the sum of these two, which makes it 2. So Fibonacci of 3 is 2, and that's what we're finding there. Okay, so that's how that works. Now let's look at it in an example in BlueJ. So I have it kind of set up here. The factorial method takes in an n. We're trying to do n factorial. And it just says if n equals 1, return 1. Else return, call the method factorial of n minus 1. No, you have to multiply n times factorial of n minus 1. So in other words, the example we gave earlier is if 5 calls this method, 5 is not 4, but 5 is 5 times 4 factorial. So it calls this method. That actually is what makes a method recursive, is that it calls itself. So this is now a recursive method because it calls itself. Okay, and that's how you do that. So if the base case is 1 factorial is 1. Any other case is its number times factorial 1 minus itself. So it will keep tracing until you get that value. Fibonacci has two base cases. If n equals 0, return 0. And I guess I could do an else if. Else if n equals 1, return 1. Else return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Okay? And I'll go back to that last one. So those are complete. And we can see, let's do system.out.print factorial 5, which is the example I showed earlier, which should be 120. And let's do system.out.print Fibonacci. We know that Fibonacci of 3 is 2. We also know Fibonacci of 7 should be 13, which is also the one I illustrated earlier. Okay, so let's just see that those work. Okay. Okay. We should get 120 and 13. Okay, so but both of those recursive methods are working. So the last thing, so one important thing to realize is in AP Computer Science, you're not going to be required to create a recursive method. You are going to be required to trace the recursive method. In other words, tell what it does. Okay, so that's what you will get a lot of practice in the modules. You can work on coding back. The coding back recursive problems get pretty difficult pretty quick, but coding back is also, writing in recursive code, which is something like I said you're not going to be required to do. So here's an example of what you will have to do. Here it is public int and do something int x. This is the name of the method. It returns an int and it is passing int. Okay? So the base case is if x is less than or equal to 0, we return 5 times x. That's the base case. Otherwise, we return do something of x minus 3, which again, that makes that recursive because do something is called do something. Okay, so let's think about the example of when x is set. So in other words, we're going to print out do something of 7. Okay, so let's look at that. Have the method here. Same method. Okay, we are calling do something of 7. do something of 7. I would just abbreviate it with D right now. Okay? So do something of 7 returns do something. So first of all, x7 is not less than or equal to 0. So we go to the else case, and it returns do something of 4. So then 4 comes into this method. Again, now x is 4. 4 is not less than or equal to 0, so we don't return 5 times x. We return do something of 4 minus 3, which is 1. Still hadn't met the base case yet. Do something of 1, again, comes in the method x is 1. Still not less than or equal to 0. So we return do something of negative 2. Okay? Now, when do something of negative 2 comes in this method, it satisfies the base case. And by the way, you have to satisfy the base case or you'll get infinite recursion. You just never will return anything. Okay, or finish the problem, finish the method. So in this case, d of negative 2 returns negative 10. Because it's 5 times x. So making sure that's right. Yes. And in this case, all of those are negative 10. So that's kind of a bad example now that I think back about it, because normally in a recursive problem, you're going to trace down, and then you're going to use that value to trace back up like we did with Fibonacci and factorial. If I need to show another video with that, I can, but this is a recursive method. It did keep calling itself until it reached an answer, but these things are just all the same thing. Okay, D7 is D4, D4 is D1, D1 is D negative 2, and D negative 2 is negative 10, which makes do something of 7 also negative 10. Okay, just not a great example, but again, I'll try to show another one if I get time. So just to show you, do something of 7. It needs to be static.